can click on the one you need. So if g of x was whatever, okay, it don't matter. If you compose, so that's what you've been learning the last 2 days. If you plug in g into f, whatever they are, doesn't matter. Or you plug in f into g. Okay. And your answer to either one of those is x. So I guess I should say if you do that or if you do that. And your answer is x. That happened yesterday. I don't know if you remember, there's a couple examples. That means, this arrow means, like that implies, okay, that means that g, they are inverse of each other. So f and g are inverse. They're inverse functions. So when you plug them into each other, since they're opposites, they completely cancel each other out, and they just leave the parent function of a line, which is x. Okay, now that one misconception, notice it says x. It does not say negative x. It doesn't say x plus 1. It has to be just x. Okay. So let's do example 1 and show you what these questions look like. Example 1. Okay. So they would read something like this. Is f function an inverse of g? Something like that. Or are they inverse of each other, or whatever. So example 1, let's try this one. Let's do f of x equals x cubed plus 1, and g of x equals cube root of x minus 1. Now remember, it doesn't matter which direction you go. It'll work either way. Okay? So let's, why don't you guys, just so our work matches, let's do f of g. So again, this means g goes into f. Okay, so this is what you've been doing the last 2 days. So go ahead and try it. Plug g into f. Okay, so I'm going to take g and plug it in. Right, so it will look like this. Something cubed plus 1. So that something is g. So g x minus 1 cubed. Okay. What does the cubic do to the cube root?
Cancels it out.
Cancels it out. So all we're left with is x minus 1 plus 1. Negative 1 plus 1 is just 0, so our answer is 6. Okay. So to the question, is f of x an inverse of g of x? Yes. It is. Okay. They are inverse of each other. That makes sense? Okay. Let's try one of these. If you guys get it, we'll stop with this one. Example 2. If you get how it works. So let's do f of x equals 4x plus 3, and g of x equals 4x plus 3 over 4. So just against our work matches, let's plug in g into f, just so that we have the same steps. 2, 1. So this goes in there, right? So here's how it would look. 4 times something plus 3. 4 times something plus 3. That something is 4x plus 3 over 4. Okay, that's the plugging part. After that, that's dividing by 4, that's multiplying by 4. So they just cancel each other out. Okay. And then you have 4x plus 3 plus 3. 3 plus 3 is just 6. And that's as much as you can go. So are they inverse of each other? No. Okay, because the answer is not x. So not inverse. Does that make sense, guys? Yes? Okay, what about, let me ask you this. What if you didn't want to compose this? How else could you determine if they're inverse of each other?
Since they're the opposite signs in the function, like if instead of 4x plus 3 could be like minus 3, or like the opposite of it.
I don't know if that's always true. I wonder though. It makes me wonder if that's always the case. What were you just doing here a little bit, right? A minute ago, weren't you finding the inverse of those? How did we do it? We would switch x with y, solve for y. So you could, in theory, just solve this, like switch x with y, solve for y, get the true inverse, and see if it's that. If it's not that, then it's not the inverse. You get what I'm saying? So you could like do it that way too. But it's good to know this. I think that's, any questions do you guys have? Okay, so as far as the notes,